Okay, in this video we are going to explain the 2013 AMC 10B, problem number 20. It says the number 2013 is expressed in the form 2013 equals a1 factorial, a2 factorial, and so on over b1 factorial, b2 factorial, and so on, where a1 is greater than or equal to a2, so this number bigger than this one, and or equal to it, and they're all in decreasing order or non-increasing at least. And same with the bottom part as well, the denominator. These are positive integers, and a1 plus b1, the two first terms, is as small as possible. The sum of them is as small as possible. What is the absolute value of a1 minus b1, otherwise known as the positive difference? So this is again a question type that I really enjoy. If you've taken the AMC for long, you are aware that they will give questions that don't really have any precedent. This is one of those questions. There's never been in the last 20 years another question quite like it. There's been factorial, of course, and things as such, but never quite in this arrangement, this dynamic. So it makes students feel like sometimes, oh, I don't know the special trick for this, therefore it's not within my capability to do this kind of problem. So what do we do as a test taker in that situation? The first thing is you have to get past that feeling of panic. You have to move that beyond that and just think, okay, I have to make headway. It's not just you that's never seen this problem type before. Neither has anyone else on the test. You have to have creative skill to be able to qualify for the AMI. If you can only do all the past problems on the AMCs, you'll probably never qualify. Right? The ones that are going to qualify are the ones that can think on the fly and be able to solve a problem that they've never seen something quite like it before. So how do we handle this? If you don't understand factorial, something like 5 factorial is 5 times 4 times 3 times 2 times 1. You stop at 1, you hit every number in between. This would be 120. That's how factorial works. You can also stop writing factorial at any point. 5 times 4 factorial, and the rest is considered to be there. You don't have to write all the numbers out. So that's what factorial is. Now, how does it apply to this problem? We've never seen a number written in terms of factorial before. Combinations of factorials and, the numerator and denominator both having the same concept in it. So where do we even begin? What you might think of is, what if I prime factored this? I don't know, let's just see what happens if we prime factor it. So 2013 is divisible by 3 because the sum of the digits is a multiple of 3. It's equal to 3 times 671. 671, if you recognize it, 6 plus 1 is 7. That means it's a multiple of 11, and it's 11 times 61. So you get 3 times 61 times 11. How can we use this in this setup? Well, if we have A1 being the biggest, maybe we could put 61 here and say 61 factorial, and then A2 could be the 11 factorial, and the last one would be 3 factorial. Okay, but what about all the other numbers? How are we going to get rid of those? That's where the denominator comes in. If we can just eliminate everything after 61, 61 times 60 times ... and the denominator starts at 60 times 59, then all of this will cancel and just the 61 will remain. So we can put 60 factorial, 10 factorial, and 2 factorial. This does at least meet the requirement that it's equal to 2013. But now we have to see, did we meet the qualifiers? It says that A1 plus B1 is as small as possible. Well, A1 is 61 and B1 is 60. If they were as small as possible, 61 minus 60 would be 1. But you should kind of have maybe your spider sense tingling a little bit to tell you this could be a trap answer. It's very common on the AMC where they have thought ahead to the mistakes that you could possibly make, and they put the mistake conclusion inside the answer choices so that you feel really good about your wrong answer. So then we should try to figure out, is there any way to reduce these two numbers? 61 is a prime. If I go down to 60 factorial, I won't have a 61. I'd have to raise this one. I need the 61 to make the 2013. So I don't think we're going to be able to reduce the 61. What about the 60 though? The 60 is there to cancel the 60 that comes right after 61. Is there any other way to cancel that 60? Well, let's think about, what if we prime factored 60? 60 is equal to 5 times 4 times 3. I wonder if I could shift these numbers to one of these. Since this is 2 factorial and this is 5 times 4 times 3, we can now write it as 61 factorial, 11 factorial, 3 factorial over, take out the 60 and go to 59 factorial, and then have 10 factorial, and take this 5, 4, and 3, attach it to the 2 factorial, and generate 5 factorial. This is better than the previous one. The question now is, can we get even smaller? If we reduce the 59 to a 58, we lose access to the prime number 59. There's no way to get it to cancel the 59 from the 61 factorial. So it looks like, and it's true, that these are the smallest A1 plus B1 that we can achieve. Their difference is 2. We've avoided the trap answer, and the answer is B.